Hello, this is a short video that I made to introduce our next topic, which is integration of trig functions. So on these problems, we're trying to integrate a complicated trig expression, and the approach we're going to use is to apply some of the identities that you used in trigonometry class, and those identities are going to let us change the integral into something that's easy to handle, a problem that you learned in Calc 1. I want to begin by reviewing the identities we're going to use. Here's the first one. It's the Pythagorean identity, sine squared x plus cosine squared x equals 1. And it turns out it's going to be most useful to us in a couple alternate forms. So for the one on the left, I subtracted cosine squared from both sides. And to get the one on the right, I subtracted sine squared. The other identities that we're going to need are the power reduction formulas. You have these on the reference sheet I gave you at the end of our last class. Here they are. All right, so let's take a look at some new problems where we use this approach. We're going to talk first about integrating powers of cosine. It turns out that you need to use a different approach for even powers and for odd powers. Our first problem is the integral of cosine squared, and the power is even. So we're going to rewrite the function that we're integrating, and we're going to use the power reduction formula from the last slide. I set that up here. So on the right side of this equation, I plugged in my power reduction formula, and the next step is to do a little algebra. I broke the integral up into two pieces. Now notice that both of these integrals are easy. They're things that we learned how to do in Calc 1. So the integration step looks like this. Just be careful, cosine 2x gives you that extra factor of 1/2 when you integrate it. And then I simplified, and so that's my final answer. Our integral is 1/2 x plus 1/4 sine of 2x plus c. That's how we handle a power of cosine when the power is even. The next thing we're going to do is look at an example of an odd power. So here's the integral of cosine cubed x. The basic approach we're going to use is to break the power into two pieces. We always split off just a single cosine x for our second piece. When I do that on this problem, I get the following expression. My cosine cubed x turns into cosine squared x times cosine x. And the reason we're doing this is to set up a u substitution in our next step. So let's take a look at the details. For my first step, as we saw, I've got to split off a single cosine x from my power. The next thing I have to do on this problem, I'm going to look at that cosine squared x. And here we're going to apply our Pythagorean identity. So cosine squared turns into 1 minus sine squared. All the work we've done so far is to set up the following u substitution. So I let u equal sine x and du equal cosine x dx. Notice that I have that expression cosine x dx on the end of my integral. So the work that I've done sets up this u substitution perfectly. In the next step, I carry out that substitution. Notice that after I do this, I have a simple Calc 1 integral just involving basic powers. So the integral 1 minus u squared gives me u minus 1/3 u cubed plus c. The last step is to reverse the substitution. Remember, u equals sine x, so my final answer is as follows. So we've seen two basic approaches. We have one approach for even powers. That's the power reduction formula. We have a second approach for odd powers. There we need to use a u substitution combined with some algebra. The way that you would handle powers of the sine function is similar. And so if you want, you can look at the first two problems on the attached problem set. These are the related problems where you have sine instead of cosine. Now I want to go on and examine some things that are one step more complicated. So we're going to have functions where we have powers of both sine and cosine. Again, we're going to break these up into two separate cases based on whether the powers are odd or even. In our first example, we have one odd power. And here we're going to use the same approach that we used to integrate cosine cubed. We're going to split the odd power into two pieces and then use a u substitution. In this problem, the odd power is sine cubed, so I split it up as you see. I take one of the sines and put it on the end of my integrand. Now when I do that, I can substitute this into my integral and I get the following expression. The next step is familiar. We're going to use a Pythagorean identity. And we want to use it on sine squared. So I replace sine squared x with 1 minus cosine squared. Now we've set up the following u substitution. I want u to equal cosine x, and here du equals minus sine x. Remember that we get an extra minus sign when we take the derivative of cosine x. When I plug that u substitution into my integral, I get the following expression. Just like we saw on our last problem, we've now changed our complicated trig expression into something just involving basic algebraic powers. This is something that we know how to integrate. I did a little rewriting on my next step, so that minus sign that was attached to the du has moved in front of my integral. I also distributed the u squared through the parentheses. As I said, this is something that we know how to integrate. There's my integration step. And then finally, I reverse the substitution. So we defined u to be cosine x, and that gives me the following expression. Just make sure that you watch your minus signs. We have a minus sign in front of the parentheses that we have to distribute. So that's the way we integrate products involving sine and cosine if we have at least one odd power. That approach doesn't work if we have two powers that are even. So this is our next example, and here we're going to use the power reduction formula for sine squared and cosine squared. I set up that integral, and on the left-hand side, I plugged in those formulas from your reference sheet. In the next step, I'm going to do some algebra, so I multiply what I have in parentheses. Here there's a nice cancellation, and I get the following expression. We break it up into two parts. The first part's just a Calc 1 integral. That's easy. And so that integral of 1/4 is 1/4 x. In the second integral, we have cosine squared of 2x. And remember, that was the first problem that I talked about in this video. So we're going to approach that part of our problem by breaking it down with the power reduction formula. And I've done that on my next step. Here we started with cosine squared of 2x. And so notice that when we apply our formula, we get a cosine of 4x. We have to multiply 2x by 2. I did some simplification of the constants on my next step, and we see that we have an easy function. We learned how to integrate this in Calc 1. When I integrate it, I get the following result, and I finished off this problem by doing some algebra and combining like terms and multiplying my factors. So our final answer to this problem is 1/8 x minus 1/32 times sine of 4x plus c. That's how you handle a problem where you have sine and cosine, and they're both raised to an even power. So there's some things I'd like you to do to follow up. I posted a sheet with just a few problems on it. I'd like you to do those for our next class. Bring them with you and give them to me at the beginning.